Bueno, hello, this is a presentation of the problem situation for the class of analysis of electrical circuits. My name is Juan Pablo Grajeda Sanchez. My teammates are Alejandro Victoria López, Marco Antonio Dávila, Nieto. As in next. For the index, we have phase one, which consists of research. We're going to talk about electronic waste, alignment with sustainable development goals, and the Whetstone Bridge, and also the phase two. The electronic waste in Mexico. Well, in Mexico, approximately 1,500 tons of electronic waste were generated in 2022, representing an average of 11.8 kilograms of e-waste per capita. Despite this, the national recycling rate of e-waste is nearly 3.5%. And over the last decade, Mexico has produced at least 6.3 million obsolete computers in a decade. This is projected to be 10 million units by 2026. Then batteries also contribute substantially to the problem, with an estimated 37 million spent batteries annually. Now, for the recycling strategies for electronic waste in Mexico, to address the growing issue of e-waste, there are various recycling strategies, such as the formal recycling centers. It could be like Recicla Electrónicos Mexico, REMSA, which recover valuable materials from e-waste and while minimizing environmental harm. There are also corporate take-back programs, such as companies like Dell, Samsung, and HP have introduced return schemes for all the electronics to ensure proper disposal and recycling. Also, awareness campaigns, both government and non-governmental organizations, promote e-waste collection programs and educate the public. And the legislative action, these are all the laws that protect the environment. These are policies regulating the collection and treatment of e-waste. All of these are emerging, although the enforcement and infrastructure development remain as a challenge. And yeah, I asked.
Alignment with sustainable development goals. So the issue of e-lights aligns closely with CDG 12, possible consumption and production, which emphasize the sustainable management of resources and the reduction of waste generation through recycling and reuse initiatives. This goal underscores the importance of implementing effective systems to manage e-waste sustainability. The Whetstone Bridge is an electrical circuit designed to measure electrical resistance with high precision. Consists of four resistors arranged in a diamond shape with a voltage source supplied across one diagonal with a galvanometer across the other. When the bridge is balanced, the ratio of resistance one branch equals the ratio in the other branch, causing the voltage across the galvanometer to be zero. This balance condition allows the unknown resistance to be calculated using the known resistance in the circuit per the formula R1 divided by R2 equals R3 divided by Rx. The circuit has several practices, applications, like precision measurements of resistance, that this is used in laboratories and industries for accurate resistance measurements, sensor circuits like commonly integrated with strain gauge to detect minutes change in resistance caused by physical variables such as pressure, temperature, or force, and the calibration of instruments, essentially in the calibration of electrical measuring devices to ensure accurate.
For the phase two, the LT SPICE initial Whetstone Bridge circuit, in which it has an initial value of 9 volts, and every resistance has a value of 15. Next. Now, if we add a value lower than in Rx is in place in the test terminals, according to the tested voltage, the voltage at terminal B will be much higher than the voltage at terminal A. It will be 1.5 volts higher than terminal A. As such, the current will be transported from terminal B to terminal A. Next. Next. Now, if we add a value equal to 0 in the test terminals, as seen at the picture, the voltage will drop to 0 in terminal A. Meanwhile, terminal B will show half of the voltage initials of voltage B, resulting in 4.5 volts. This creates a voltage difference of 4.5 voltage between terminal B and A. Backwards, yeah. And if the Rx has a greater value, in this case of 70, and the voltage at terminal A becomes higher than the voltage at terminal B. This results in the flow of current shifting accordingly. In this situation, the difference of voltage is 2.76 volts. Next. Yeah. Oh, backwards. Yeah. And now if we add a equal value to infinity, the test resistor is set to an infinite value. Terminal A will match the initial voltage of 4.5 volts, while terminal B will raise to 176 megavolts, half of the initial voltage value. Next. Develop a model to calculate Rx using voltage and resistors. To develop a mathematical model for determining Rx based on voltage measurements and known resistors, you can use the principles of ohms and voltage divisions, as seen in the left picture. Now, the next step is solving for X, combining equations for the intensity. And to validate the isolated resistors, we can compare the calculated Rx with the value indicated by the resistor's color code. If they match within an acceptance tolerance range, the resistor is reusable. Next. Thank you for your attention.